next few slides set out all the elements and assumptions of the base case. For example, did you know that the official forecast for population are an 18% growth in the next 20 years, and an even higher growth than that in the over 60s, in the number of households, and in one adult household in particular. And one interesting finding from our work is that smaller households make more long-distance trips per head. We use the April 2009 Treasury forecast for GDP growth, and that sees a recovery to 2.5% per annum GDP growth by 2012. Well, who knows? I know there have been more recent forecasts, but this is the one we modelled during our study in 2009. And we take a mid-forecast for oil prices, which may now seem a little conservative. Other base case assumptions are spelt out here. Take a moment to look at these. Now, you may believe that a worsening of only 7.5% in road journey times by 2030 is optimistic, and we probably do too. Nevertheless, that's our base case assumption. But we so disbelieved the Department for Transport's forecast of a 25% reduction in airfares that we actually took half of it. So having put all this in the model, this is the base case forecast. A 30% rise in long-distance travel by car, 35% by rail, 25% by coach, and an amazing 125% increase in long-distance travel by air. And the overall growth is 34% in the total amount of travel over 50 miles by 2030. I must emphasize at this point that these are forecasts of demand at today's level of service offered by the transport networks. This means they do not take account of capacity limits on the road and rail networks and the effect these capacity limits might have on the levels of service offered and therefore back on demand. The one exception is the assumption of a 7.5% deterioration in road travel times by 2030. Here then are the alternative scenarios that we tested. First of all, we tested increasing rail fares by the retail price index and not by the retail price index plus 1 percentage point per annum. Another was to test road user charging, and for this we applied a generic 5p per kilometre for business and commuting travel, reflecting more peak period use and the use of busy roads, and 2p per kilometre for other journey purposes, most of which is outside peak periods, and some of it at least not on the busiest parts of the road network. Because this is a model of aggregate demand and not geographically specific, we could not represent a road charging scenario any more accurately than this. We tried a £10 increase in air passenger duty for domestic travel above what it is now. And then we tried 2 levels of fuel efficiency for cars. Our base case is a 23% improvement in fuel efficiency, which generally allows fuel price increases to be offset by fuel efficiency improvements, and so the cost per mile to the driver is more or less static. The worst case we assumed is where there's no increase in fuel efficiency, and we also tried an optimistic case of a high fuel efficiency increase which reduces motoring costs by 10% by 2030. And separately, we tried the effect of increasing motoring costs by 1% per annum for a range of possible reasons. And finally, we looked at the effect of much lower GDP growth. Supposing GDP from 2012 grows at only 1.25% instead of 2.5%, which is the base case forecast, what would be the effect of that on long-distance travel? Well, this slide shows the percentage growth from 2005 for the base case, and then for each of our different scenarios, the percentage growth by each mode which the model has presented to us. Now, I'm going to highlight key points in red. For example, the level of road user charging we applied, which is 5 pence per kilometre for business and commuting, and 2 pence per kilometre for the other three journey purposes, it reduces car travel from a 30% growth to a 27% growth. But it does proportionately put a lot of additional travel onto rail, and so we see a 48% growth in rail by 2030 instead of a 35% growth without road user charging. Interestingly, this increase in rail is not as much as the effect would be of holding rail fares constant in real terms. That's a 60% growth in rail. That illustrates again the acute price sensitivity of long-term travel demand on rail. Higher motoring costs at 1% growth per annum do affect car travel and again divert some travel to rail and to coach. And note on the right-hand side that the total growth of long-distance travel drops 8 percentage points from 34% growth to 26% growth. These sensitivity tests on the bottom line show just how important income is in driving long-distance travel. If GDP growth is 1.25% instead of 2.5%, the total growth in long-distance travel is 18% compared with 34%, and long-distance rail doesn't grow at all. This shows the effect of assuming that fuel and energy efficiency of car travel improves even faster than government assumptions, and that may be possible. This will of course reduce motoring costs as a result, and so it generates some additional growth in travel, a 36% growth in travel by car rather than a base case growth of 30%. One thing we decided late on in the study we would like to have done, but we had no more funding to do, is to carbon footprint these different scenarios. We would like to have done an analysis of carbon emissions of our 2005 situation, the base case in 2030, and the alternative scenarios. This would have brought out the effect of the differences in carbon emissions between different modes of transport. And don't forget that long-distance travel accounts for 30% of all travel mileage. Well, that's the next piece of work. So what are the conclusions of this research? First, long-distance travel is set to grow a third in the next 20 years, largely driven by income, but very differently between modes. Road charging may cut long-distance travel, but is likely to push proportionately a lot of demand over to rail and less so to coach. Rail continues to have a strong underlying growth, but that growth is very price sensitive and GDP sensitive too. Different levels of car fuel efficiency do affect levels of car travel significantly, as would a 1% per annum increase in motoring costs. Generally, cross-elasticities are not really significant, and the effect of changes in mode impacting another mode only really show up when people are diverted from their car, in spite of the numbers as a proportion of car users being relatively small. These numbers have a large proportionate effect on modes such as rail and air, where the total numbers involved are rather less. Income is the single most important driver of long-distance travel. But the most powerful policy lever on total travel and on car travel is the cost of motoring, either through fuel costs, lower than expected improvements in fuel efficiency, or other increases in the cost of motoring. Nothing you can do with rail, coach or air travel will have much impact on travel by car. Thank you. That is the end of this presentation. I hope you found it interesting. For further information about this piece of work or about the Independent Transport Commission generally, please go to our website.